PAT review session. Most of you guys aren't doing the PAT, but that's okay because, for the love of math, right? So all we're gonna do today is just go through some math questions from the PAT. This was a released exam from 2015, and we'll just go through it. If you ever need me to slow down, or if you want to try solving the questions yourself and you want me just to, be quiet, just raise your hand or something. If you have any questions, raise your hand as well. And we can get started with the first question. So, can you guys read this? Can you guys see it?
Too small.
Is it too small? I can't actually zoom in, unfortunately. So, I don't know if you can come up here. Maybe we could set you up with more space somewhere. No, some of the questions are really long. Do you want to try to move to this side? And then we can just move it around. Sorry, I'm just going to move your table. It's too long. Sorry. So everyone can see now? Alright, so the first question is, we're looking for another way to represent this expression, 2 to the power of, or 2 over 3 to the power of 4. This is a question about exponents. It's relatively simple, but one of the things that you really have to be careful with is not to get tripped up, because if you notice, both C and D look really familiar, or really similar. But okay, let's just go through the question. So what we know is exponents is just repeated multiplication, right? So when it says 2 over 3 to the power of 4, it means 2 over 3 times 4, or times itself 4 times. So what we get looks something like 2 over 3 to the power of 4 is equal to 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3. Okay, so that's pretty simple. And then you see that there's only 2 answers that sort of look like that. It's either C or D, and I think the PAT people were trying to trick you when they put in C, because the plus sign sort of looks like the multiplication sign. So you have to be careful there and pick D. So the correct answer is D. One of the things with the PAT that you should definitely remember is there's a lot of sort of tricky questions like this, so you should have some tools in your skill set just to make sure you know how to validate them. So what I did when I wanted to just make sure that all my answers were correct here, I just pushed it into a calculator. You get a scientific calculator for this exam, you might as well use it. I think I ended up getting A would look something like, I think it was 0.6. It was 0.75, I think. B was 0.6, C was also 0.6, and then D was 0.19, and then 2 to the 3 to the power, or 2 over 3 to the power of 4 is 0.19. So we use sort of a validation just to make sure that we're right, but this question was pretty quick. Is that one okay? Pretty simple. Let's go to the next one. So this is a question about just your understanding of the number line. I think this one is primarily designed to try to, basically I think it's trying to trick you, especially with the negative numbers. The negative numbers can get really confusing sometimes. This is a really negative, this is a relatively more negative number. Is this more negative? Because more is further right. No, be careful with the direction in negatives, right? So if you just look through each of them, I think there are 2 strategies you can go with, and it's good to try to be consistent. So you notice that they're in different forms, right? One is in decimal form and one is in fraction form. So the way I like to do it is I like to keep it in one form, just so that I don't get tripped up, or I don't trip myself up. So if I personally did fractions for this one, and if you actually look at the interval between each integer, there's 1, 2, 3, 4, 5, 6, 7, 8. So everything's in intervals of 1/8. So if we turn each of the numbers into fractions with a denominator of 8, it looks something like -1, 6/8, 1, 5/8, 1, 1/8, and -7/8, right? So -1, 6/8. 6/8 is 2 less than 8/8, or at least that's how I thought about it. So then you move to decimal places. So you know this is located at point 1. 5/8. It's all counting. It's 1, 5/8. So you count 5 from 1. 1, 2, 3, 4, 5. This is 7. 1, 1/8. You count 1 from 1, which is 6. Pretty simple. And then -7/8. You count 1 to the right, because just remember your directions with the negatives. You count 1 to the right, so 1. So then 6 and 4 respectively. And then your final answer ends up being 1764. Let me make sure that's right. Yeah, okay. Next question. Is that okay? And you can try all these questions if you want. Oh wait, okay, so actually this one's a bit of a weird one. Please try it because I couldn't solve it. So yeah, like I don't know how to solve this question. It's really weird. You guys can give it a try, and then maybe we can talk about it for a little bit. This is gonna be our little break in between a lot of questions. Yeah, I have no clue. I'll tell you the right answer if you figure out a way to solve it, but I have no idea how to solve this one. And that's not just like me being sarcastic. Like I literally don't know how to solve it. And if we can collectively agree that there's no solution, then we'll move on. Does anyone have any ideas about this one? Can we kind of collectively agree that there may or may not be any solutions? Okay, so the reason why I have no idea how to solve this is because, well, Aaron's meal costs $7.30, right? We can just do the addition on that. Sam's meal is less than $7.30. Too bad that there's no $7.30 anywhere on these number lines. And then his soup costs more than his salad. He buys a soup and he buys a salad. His soup is $2 more than the salad. But the thing is you don't know how much the salad costs.
There is a correct answer.
There is a correct answer. It's D.
Yeah.
Oh, can you explain why? I'm not actually sure why.
I'll show you.
Yeah, I actually don't know why.
Okay. So the total cost for Aaron is 6.5 plus 80 cents. So it's $7.30, right?
Yeah.
So for Sam is less than that. So Sam's cost should be less than this one. So first, let's assume Sam cost actually exactly $7.30. So I use elementary math, okay? So let's say the salad is like this. And then, what more than that? So this is the soup, right? The soup is salad plus $2. So then the total, if it is $7.30, so $7.30 minus $2, then you got $5.30. So you divide by 2. This one divided by 2. So you got the salad. You got salad. So it's $2.65. And Sam's cost is less than this one. So it's so actually this one is less.
Right.
So it's not included $2.65.
I read the question.
Right?
I thought it was the meal of the cost of Sam's meal. Okay. Yeah.
Maybe you can explain to them.
Oh no, does everyone understand his explanation? It was a lot better than mine since I didn't understand the question. Okay. Hopefully that was good. I personally read the question wrong. I thought it meant Sam's meal, which is actually impossible, but it was actually the price of Sam's salad, which is the more expensive one, or the cheaper one. So this next question is considered one of the hard questions. The way the PAT is actually organized is, let me just make sure here. There's about 50% of the questions are relatively easy questions, 40% are considered intermediate complexity, and then 10% of them are what you call like very complex or very hard. They expect, not a lot of people, they would only expect like the top couple students to be able to actually solve these top 10% of the questions. This is one of them. So I think obviously the harder questions, you really have to get a sense of how to solve them. And the only way that you can actually get a sense is to actually try to solve them yourself. So I'm gonna give a little bit of time for this one, because this one's actually pretty complex. And keep in mind, this is just an approximation, and that's why it says best represents. You can't actually, like, there's no exact way to figure it out. And remember, you actually got to use a calculator. Do you guys have a calculator? I can toss you guys some. Because personally, I use a calculator for this question. You're not allowed a graphing calculator, but I'll just give you. I have another one. So what the question's basically asking is, we have two numbers, P and Q, and they represent consecutive perfect squares. So an example of two consecutive perfect squares would be something like 9 and 16, because they're consecutive and they're also perfect squares. So what they're asking is, if you have, where does the square root of the average of P and Q lie between the square root of the individuals? So the way I solve this, and I think this is the way that it was intended to be solved, is basically you just try consecutive perfect squares. So one example, the one that I did that I think makes a lot of sense is 3 and 4 squared, which is 9 and 16. So if I had P was square root 9 and then Q is square root 16, we obviously know that P is 3 and then Q is 4. So then what's the value of this square root of P plus Q over 2, which is around 12.5? If I remember, I punched it into the calculator and I got about a value of like 3.55 something. So, I mean, I think you can sort of tell 3.55